Welcome, everyone. Welcome to Straight Science. Straight Science is an evening lecture series put on by University of Alaska Fairbanks Northwest Campus in Nome and University of Alaska Fairbanks Alaska Sea Grant in Nome as well. And tonight you're in the work office, and it is a very lovely 44-degree spring day with sun and practically no wind, and it is gorgeous outside. So both Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. We serve all peoples of the region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. So tonight, this is a good straight science. This is the start or the kind of the kickoff for us, I guess you'd say, for a straight science night on the Northern Bering Sea Integrated Ecosystem Research Program. And tonight's speaker is Danielle Dickson. She is a senior program manager at the North Pacific Research Board. Often the acronym is NPRB. You'll hear that. And they're in Anchorage, and we'll hear more about NPRB, and we'll hear more about this overarching larger project that's going to be in the Bering Strait region, Northern Bering Sea, for the next 5 years. So we're very excited to hear and learn more about it. And we thank you, Danielle, for taking time out of your busy Thursday night, and you're not even at home. So you and I are both staying late, and we very much appreciate your time. Take it away and tell us about the North Pacific Research Board and the Northern Bering Sea Integrated Ecosystem Research Program. We are all ears. Thank you so much for coming.
Hey, Gay. Thank you so much for having me, Gay. I really appreciate it. Good evening. Thank you all for welcoming me into your homes this evening to introduce our new Northern Bering Sea Integrated Ecosystem Research Program. Give me a moment. I will share my screen here with you. Gay, can you see my slides?
Yep, looks fantastic. You're in
Great.
presentation mode.
Great. Thank you. Yes, so I want to begin by just acknowledging that this research program will involve more than 60 people, and I couldn't list them all here on the slide. So I want to acknowledge everyone who's going to be involved in this research program over the next 5 years. And I have listed here some of the people who are taking a leadership role, but please know that there are many, many other people involved in this program who I couldn't include on my slide. So I want to just take a moment to introduce myself. I was raised by Francis and Eugenia Savarese on the North Shore of Long Island, New York, where we throw W's into words where they don't belong. And this photo in the center is a picture of the beach where I grew up taking swimming lessons and spending my summers on the North Shore of Long Island in Long Island Sound. And I remember my nana collecting mussels off of that jetty there and bringing them home to steam and cook for dinner with pasta. She was born and raised in Naples, Italy, and she just loved to make fresh seafood pasta at home. And I remember when I was in elementary school, we began having harmful algal blooms, and that meant that she was no longer able to do that safely. Um, and I should mention that that beach and the area where I was raised are on the lands of the Nissequogue. In elementary school, I also grew up going on field trips to the Whaling Museum in Cold Spring Harbor, New York. Whaling was also a big part of the culture there in the North Atlantic, where I was raised. And I began at a really early age developing a love for the ocean and marine mammals, and decided to pursue a bachelor's degree in marine science at Southampton College of Long Island University on the lands of the Shinnecock. And then in 2001, in June, it'll be 25 years ago, I moved up here to Alaska, to Anchorage, and I've been living and working on the lands of the Dena'ina ever since. I did my master's degree research on harbor seals at the terminus of the Bering Glacier on the coast of the Gulf of Alaska, and then I worked for a few years for the Alaska Native Harbor Seal Commission as their biologist and biosampling program coordinator. I also worked as a marine mammal biologist in consulting for about 5 years, and Among the different projects I did included doing marine mammal observations offshore on vessels in the Arctic. And about 15 years ago, in 2011, I joined the North Pacific Research Board to manage their integrated ecosystem research program. And so at that time, we were managing a program that focused on the Gulf of Alaska. And then following that one in 2016, we began an Arctic-focused program that collected data in the Bering Strait and Chukchi Sea. And I'll tell you a little bit more about that program in just a moment. And now we're here about to begin our new Northern Bering Sea focused integrated ecosystem research program. So that's a quick introduction to myself. And I want to make sure to acknowledge that my another important role, and frankly, in my mind, more important role is as wife and mother. This is my daughter, and she is growing up to be a budding little marine biologist herself, and that's been a lot of fun. So I want to say a few words of introduction about the North Pacific Research Board. We are an organization that provides funding for marine science research in Alaska waters to provide a better understanding of Alaska marine ecosystems. And I have a link to the NPRB website here. We have a diverse 21-member board. They represent interests ranging from the federal government to private industry, environmental organizations, and we also have 2 Alaska Native interest seats on our board. And we provide research under a number of different programs. We have a core program that provides sort of discipline-specific research projects, funding for those projects. We also have an outreach program that goes hand in hand to provide funding for outreach for those core program projects. We have a Graduate Student Research Award program and a long-term monitoring program, both of which I manage. And then we also have the Integrated Ecosystem Research Program that you'll learn more about today. You can find more information about our other programs on our website. So the Integrated Ecosystem Research Program is designed to study processes in marine ecosystems that link ocean physics and chemistry to marine life, and they include studies of the interactions among species. And they're unique in that we bring together a team of scientists, usually between 50 and 100 scientists, who work together over at least 5 years, and they share what they know about the ecosystem. And the results allow us to better understand connections from things like warming water temperatures to changes in the distribution, abundance, the timing of migration of marine species, for example. And the thing that makes this program unique is that it really takes a holistic view of the ecosystem. And when scientists are trained, they get their PhDs in a relatively narrow field of science. So they're experts in a given field, whether that's physical or chemical oceanography or plankton biology, fisheries science, marine mammal or seabird research. And these programs really bring folks together, and they allow them time over the course of 5 years to learn the language of other disciplines. They all start out using completely different statistics, using different sets of jargon, and it takes time to really break down those silos and start putting together this holistic picture of what's happening so you can get to really understanding those processes that are at work that really determine the structure and the function of an ecosystem. And they really allow you to build relationships over time. And these programs also, not only because you have people getting together every year, building relationships and talking about their science iteratively, they also provide us a really wonderful opportunity to include people who can bring local and traditional knowledge so that you can use that knowledge alongside Western science to really get a much better picture of what's happening. And it's so powerful to include people in the research program who are living in that ecosystem all year round. They're seeing the changes throughout the year. They really bring not only thousands of years worth of context, but also that seasonal context that the scientists don't get when they just go out on a research vessel for 3 or 4 weeks a year and then go home. And so why study the Northern Bering Sea and why now? To understand that, I want to take you back to our previous integrated ecosystem research program that focused in the Arctic. And that program looked at how reductions in Arctic sea ice and the associated changes in the physical environment influence the flow of energy throughout the Chukchi Sea. So this program focused in the Chukchi, and it ran from 2016 through 2021, and it collected field data in 2017, 2018, and 2019. And I have a link to that program's website here. And as the North Pacific Research Board was developing that program, at the time in 2015, there was a marine heat wave happening in the North Pacific, and it ended up being termed the blob. And as we were discussing that, we wondered, is the Chukchi Sea an ecosystem that is resilient to marine heat waves that persist across years, like the one that happened in the Gulf of Alaska? Because in the Chukchi Sea and the Northern Bering Sea, even if you get a really warm year, you may get sea ice come in the winter, and does that just reset the system every year so that even if you got a warm year, you wouldn't see that warming compound year after year after year? So was the Chukchi Sea an ecosystem that's resilient to marine heat waves? Well, in 2017, 2018, and 2019, we learned the answer, and it was no. And this is why. So when sea ice comes in, it forms this pool of very cold, dense, salty water that sits near the seafloor. As sea ice forms, it rejects salt, and that cold, salt, dense water sinks to the bottom, and it creates what we term the cold pool. And that pool of cold water sits on the bottom. And one of the things that it does is it typically restricts the northward movement of subarctic fishes like Pacific cod and walleye pollock that are important fishes to commercial fisheries in the southeastern Bering Sea. And so our research program was out collecting data in 2017, 2018, and 2019. And over those years, waters got progressively warmer, and they warmed all the way to the bottom. So that by 2019, those cold waters were more or less absent from the US side of the Bering Strait and Chukchi Sea shelf and the Bering Sea. And I don't know if you can see my cursor here, but when I say cold water, I mean waters that are less than 2 degrees Celsius. And so the cold pool, the really kind of dark purples. And you can see in 2019, the colors all shifted toward that yellow. So that dark, cold purple water was gone. And by 2019, without that cold water barrier there, we observed subarctic fishes, those Pacific cod and walleye pollock, swimming straight north up through Bering Strait into the Chukchi Sea. And we also happen to see that Arctic cod that tend to be ubiquitous, they're always under normal conditions found throughout the Chukchi Sea. They're considered a keystone species. They are very well adapted to living in cold waters, and they're very good at storing fat. And so comparatively, they are very nutritious, very fatty fish for their consumers. And so by 2019, in that Arctic program, whereas in earlier years we saw Arctic cod throughout the Chukchi Sea, by 2019, those fishes had shifted their distribution all the way to the northern end of our study area and were only found up near Point Barrow. So because we were taking this holistic approach to studying the system, coincident with studying the changing water temperature, we were also sampling every other aspect of the environment. And so we were able to see really profound changes at every level of the ecosystem, from the phytoplankton to the zooplankton, the fishes, the marine birds and mammals. So for example, the phytoplankton and the zooplankton we saw fewer of those really energy-rich Arctic cold water adapted species, and we saw more of the subarctic species that are not very well adapted to storing fat. And so any of the consumers that would have eaten them would have had to eat many more of them to get the same amount of energy. And then the same thing as we saw those Arctic cod disappear from the system and the Pacific cod and walleye pollock move in, we also saw those fat-rich fish disappear and be replaced by fishes that were relatively less nutritious for whatever would have eaten them. We also saw that we had acoustic recorders out to listen for marine mammal calls, and we heard humpback whales, fin whales, and killer whales staying in the Chukchi Sea ecosystem for longer periods of time as the sea ice was absent. So we heard those whales well into late November and early December, whereas in earlier years they would have swum south far earlier than that. The other important thing to know about Pacific cod and walleye pollock moving northward is the adult forms of those fishes are voracious feeders, and they will eat up whatever they can find on the bottom. And so the Chukchi Sea ecosystem is a very rich benthic, has a very rich benthic environment. It's a shallow sea, so the water's only about 40 meters deep. So the plankton that bloom in the surface don't have very far to fall if nothing eats them before they reach the bottom. So that ecosystem has a very rich benthos. However, as you have more of these subarctic voracious groundfish coming in, eating things off the bottom, it could really begin to change that ecosystem. So that the collaboration among scientists working in different disciplines really allowed that team to connect the dots to put together what was happening in that system and link things like changing water temperature all the way up through the whole ecosystem. And they were able to work together to produce papers like this one that was able to provide varying lines of evidence showing that this ecosystem may be in a state of transition. So the North Pacific Research Board, as they thought about where a future integrated ecosystem research program would focus, decided that they really wanted the next program to focus on the Northern Bering Sea and continue research into what was happening here. And when they put out the call for proposals, they had a two-stage proposal process. So we first solicited pre-proposals, and then a selection of those were invited to submit full proposals. And for any team that put forward a full proposal, NPRB provided $10,000 that the applicants could use to further develop their full proposal with Alaska communities. So to do things like communicate with people in the region about how their research could be providing information that was even more relevant to their concerns, to talk with people about how community members would like to be engaged directly in the research. And so the projects that the board ended up funding include participants from the native village of Savunga, as well as Nome Eskimo communities. So you see Emma Pate pictured here. She's involved in all of our projects. And this is a photo from a meeting we finally had in person here in early April, and we had 5 of our collaborators from Savunga there helping to develop this research that's going to happen over the next few years. So some of the things that our program will be doing is collaborating with hunters from St. Lawrence Island to collect blood, muscle, and blubber samples to measure mercury levels and also to contribute to the food web research. A master's student from Savunga is going to be trained to conduct the mercury analysis. We'll be purchasing equipment and supplies for the community of Savunga so they can engage in the science directly. We'll be conducting ocean acidification sampling and analysis. We'll also be expanding the harmful algal bloom research that will be done in the context of this program and adding some toxin sampling as well as studying the phytoplankton themselves. We'll be establishing a digital data archive in Savunga, so they'll have a local computer server that will have a copy of the data collected by this program. So they will have capacity there on island to do research with the data, and they won't have to rely on an internet connection to download that data. And the team will be making regular trips to St. Lawrence Island to share results and provide educational activities. And we'll be employing community members on our research cruises and also to collect samples near their communities. And I'll talk more about that as I talk about each of the different projects. So here's a photo of the team. As I mentioned, we finally just were able to get folks together in April. This program was a little bit slower to get started than we had hoped. In the fall, we had hoped to be getting this program kicked off, and we were delayed by a very lengthy government shutdown. With a large number of our team are employees of NOAA, and so we had to wait until they were able to come back to work and until we could get their award signed and get them the ability to travel. And so we've been making progress to integrate across the different projects that have been funded, but it has been taking a little bit longer than we had hoped. But as you look at this picture, I hope you'll see some familiar faces. Several folks from St. Lawrence Island, as well as Emma is in there too. So as I mentioned that we've been a little bit delayed in getting our program off and running. So we are working on an integrated science plan, and that's coming soon. It will be available on our website, and we do plan to distribute it as soon as it's finished. So when the board made their funding decisions, they funded 2 projects that focus on oceanography and lower trophic levels, that being the prey base in the environment. So the phytoplankton, the zooplankton, and the larval stages of fishes and invertebrates. And one of those is led by the University of Alaska Fairbanks, and the other is led by the NOAA Alaska Fisheries Science Center. And then the other project is at the upper trophic level, so the consumers in the ecosystem, looking at food web effects on species distribution and interactions in the Northern Bering Sea. And that's also led by the Alaska Fisheries Science Center. And so some of the scientists involved in the program are here, and when we get to the question and answer period at the end, I will be happy to let them chime in with the detailed answers to the science questions. But here's the map on the right. This shows a comprehensive look at all of the locations where we plan to be doing our work in the context of this program. It's important to know that this map includes all of the stations and all of the moored instruments that will be out for all 3 projects. So it's a very busy map. It looks like there's a lot going on, and it looks a little overwhelming. But I want to point out that the sampling will be happening in different years and different seasons, and we will not have work going on in all of these places at once. So you'll see as we kind of go through the presentation that we'll have vessels out at different times. The other couple of important things to know, or one of them, is that we are leveraging ongoing standard surveys that NOAA does on a regular basis. So for example, those yellow dots there across the map are the sampling stations that NOAA does with their standard surveys. So this program is not adding a whole nother set of those stations. We are leveraging that survey and the data that comes off of it for the analyses for this program. We are adding some research right around St. Lawrence Island in response to the interests of the communities there. We also, at any one of these stations, the vessel will be transiting along and stopping at each one of these stations just for a number of hours, maybe only once or twice a year, as they go through this program. So while it may look like there will be a lot going on in the water, the amount of time the vessels will be at any one location is relatively little. The stars on the map also point out locations where we plan to put out moored instruments. So these will be instruments that sit on the seafloor and collect data throughout the year, including during the winter time. So we can get that year-round look at what's happening near the seafloor. So in the face of rapid change in the Northern Bering Sea, this program builds collaboration among researchers and knowledge holders to identify important processes that structure the marine ecosystem and food webs, thereby enabling responsible stewardship of important commercial, ecological, and subsistence resources. Our objectives are the following: to characterize seasonal and annual changes in the physical and chemical environment of the Northern Bering Sea, to understand how physical conditions, including sea ice, temperature, and mixing of the water column, affect plankton growth, species composition, and the timing and size of blooms that support marine food webs in the water column and on the seafloor. To determine how changing food webs and environmental conditions affect populations of ecologically, culturally, and commercially important species. To foster community partnerships to improve our understanding of factors affecting subsistence resources and food security, and to collect data to improve physical and ecosystem models that inform fisheries management and predict future changes. So as I mentioned, we have two projects that are focused on the oceanography and the prey base. So one of them being led by the University of Alaska Fairbanks and the other by NOAA. So I'm going to talk about each of them in turn. I'll start with the project led by the University of Alaska Fairbanks. That one's led by Dr. Sarah Minks, and she wasn't able to be here with us this evening, but Kay McMonagle is here to field questions about that project. So here's some photos of the team. You'll see that the native village of Savunga is a partner on this project. And their hypotheses really center on the idea that stratification or the layering of water in the ocean in the Northern Bering Sea is a very important driver of conditions in the ecosystem. So their idea is that in years where winds are predominantly out of the north and you have heavy sea ice and colder waters, the ocean is more stratified. So you have a strong boundary between that cold pool of water at the bottom and the surface waters. And you have particle accumulation along that density interface, along that boundary between those really cold, dense waters of the cold pool and the waters above it. And then in a warm year, when you have winds coming predominantly out of the south, you have less sea ice, you have more winds, and you have more mixing and warmer water. And those you have less stratification, meaning there's a less strong boundary between the bottom waters and the surface waters, and you have deeper mixing. So you have a smaller cold pool, more mixing, you have less of those really fat-rich prey resources in the phytoplankton and the zooplankton in the surface waters. You also have higher potential for blooms of much smaller cells of phytoplankton, which include the ones that can cause harmful algal blooms, like Alexandrium, that can cause paralytic shellfish poisoning. The other thing that's important here is that those Alexandrium cells, after they bloom, they will send cysts that rest on the seafloor that then sit there and wait until conditions are right. And then they can come back up into surface waters and start another harmful algal bloom in the future. And when you have greater mixing, we may have the potential to resuspend or bring those particles from the seafloor, those cysts, back up into surface waters and have greater potential for another harmful algal bloom in the future year. You also have those subarctic fishes like Pacific cod and walleye pollock moving northward and potentially also eating those organisms that are on the seafloor, including potentially the juvenile snow crab, for example. So this research project will be conducting their work aboard the vessel Sekuliak in September of 2026. I believe their dates right now are September 1st through 18th, and they will also be out in 2028. They do not plan to be out on the water in 2027. And this is a look at the stations where they will be working. The stars are where they plan to have moored equipment out, and the blue triangles are where they plan to be collecting samples from the vessel. So they will be looking at characterizing the stratification, that layering in the ocean, nutrient dynamics, and productivity. So they'll be taking a careful look at the ocean temperature, salinity, the chlorophyll, so the plankton in the water. They'll be looking for those harmful algal bloom species. They'll be looking at the nutrient dynamics and looking at productivity, and they will be comparing what they see in all of those things, especially the plankton, in those different layers of water. So they'll be taking very detailed fine scale measurements, and they have an instrument that they can tow behind the ship. You see in the image here. It does not touch the seafloor. They tow it up and down through the water column behind the ship, and it takes very detailed measurements of the oceanography as well as the plankton, and it has a camera system that can take images as it flies through the water of all the plankton, including the very, very small larval stages of the zooplankton, the fishes, the larval benthic invertebrates. The other interesting thing is that this can capture images of the soft-bodied organisms like the jellies that are very difficult to sample using things like nets, because as you tow a net through the water, it just squishes and destroys them. So this instrument will get some really nice looks at some things that you can't get typically using the nets that are used off vessels. They'll also be looking at the stratification effects on plankton communities, as I said, comparing for the phytoplankton and the zooplankton, what they're seeing in those discrete water masses up in the cold pool water above and below it, as well as right in that boundary layer. And they're expecting to see some differences in what they see in those layers. And as I said, they'll also be doing some experiments to look at the role of resuspension of those cysts for harmful algal blooms, doing some incubations on deck on the ship. They'll be linking plankton to particle composition, aggregations, and benthic pelagic coupling, so that the benthic side of the ecosystem is the seafloor, and the pelagic is all those things in the water column. And so they'll be looking at things like how quickly the particles that are in the water column fall to the seafloor, and those connections from what you see in the water to what ends up on the seafloor, and whether that is changing over time with a changing ecosystem. So this is Sarah. She is the lead for that project, and she is very happy to field questions via email if you have questions about her science. And I do have a slide at the end that shares her contact information again, as well as the emails for all of the leads on these projects. So the next one that looks at the oceanography and the prey is this one, led by Dr. Julie Keister of the NOAA Alaska Fisheries Science Center, that looks at impacts of sea ice loss on lower trophic level productivity in the Northern Bering Sea. And you can see that Emma Pate and the Nome Eskimo community are partners on this one. And all of these projects, I should have mentioned, are collaborations with other institutions. So although NOAA is the lead, they are collaborating with other universities, University of Washington, Oregon State University, and Bigelow Laboratory in this case. And they'll be looking at how ocean warming and variability in sea ice affect the nutritional quality and productivity of the prey species in the Northern Bering Sea. And these are their hypotheses. They're looking at they're hypothesized that changes in wind and ice will interact to alter vertical structure, advection, and nutrient flux. So again, that the layering in the water and the flow of water is a really important driver in things like the plankton blooms that set up the prey base for the whole ecosystem. They hypothesize that the timing of spring ice melt impacts ice algae, phytoplankton, zooplankton, and ichthyoplankton communities, the larval fishes. That changes in the above affect the nutrition available for food webs, and that sea ice loss will increasingly impact fish and food webs in the future. And they're wondering how these processes differ north versus south of St. Lawrence Island. So they will be out conducting research aboard a NOAA ship in June of 2027 and 2029. So they will be out in odd years, and they also plan to be leveraging these this moored equipment that you see at those stars. So there's just one set of moored equipment that all three projects are using. And they will be out at sea sometimes in the fall just to turn those moorings around. An important point about those moored instruments is that many of them are not capable of sending back data in real time. So they put these instruments out on the seafloor, and they collect data near the seafloor in the lower water column throughout the year. And then they come back the following year, and they have to pull that equipment up to download the data and get it back. And then they put it back out again for the following year. And so you can't get the measurements from those in real time. Most of them, you have to wait a year to get them back. So they'll be looking at how changes in wind and ice alter the vertical structure, advection, and nutrient flux. So they'll be looking at hypotheses like the loss of sea ice will reduce the stratification and increase mixing, that increased advection of warmer water from the southeastern Bering Sea will increase bottom temperatures, and that changes in advection and stratification or layering will affect nutrients and therefore plankton blooms. So they'll be conducting some measurements off the vessels in June of 27 and 29. They'll also be using those moored instruments as well as putting out a few pop-up floats. So these will sit on the seafloor and measure properties in the cold pool, and then when they trigger them, they will come up to the surface and transmit their data. So we'll have some of those pop-up floats to get some data in between. And then they'll also at times be using a glider that will operate autonomously and collect samples. They hypothesize that in cold years, you'll have abundant ice algae and large plankton blooms and a relatively healthy food web. That in warmer years, you have an earlier ice melt, less ice algae, and a less productive food web overall. And that in very warm years, you may have no spring ice, a small and a late plankton bloom, and few zooplankton and fish. So both of these oceanography and prey-based projects are testing similar hypotheses. They'll be using new and historical measurements of things like the timing of ice melt, plankton species and their size composition, flux to the sediments, and plankton growth and grazing rates. And then to look at how physical changes affect the nutrition available for the food web, they'll be collecting ice algae both from aboard the ships as well as cooperating with No Eskimo community and the native village of Slavunga to have people in communities collecting ice samples using cores to get at that ice algae. They'll be collecting phytoplankton, zooplankton, and ichthyoplankton, and all of those things will feed into food web analysis. They'll be using things like compound-specific stable isotopes and fatty acids to look at how energy is transferring from sea ice and phytoplankton all the way up through those different levels of the food web. And they'll also be looking at what the future impacts of sea ice loss may be on fish and food webs, leveraging NOAA's Changing Ecosystems and Fisheries Initiative modeling program. So our data collected by this program will contribute to developing and testing the models, and then those models will be used to provide predictions of future ecosystem properties. So Dr. Julie Keister of NOAA is the lead for that project, and she is happy to field questions about her work. That's her email address, and I will show hers again at the end as well. And finally, our third project on food webs and species interactions is led by Rob Suryan, and he is here tonight, so I will let him answer questions about his project if they come up. He's collaborating with University of Alaska Fairbanks, University of Washington, Nome Eskimo community, and the native village of Savunga to look at food web effects on species distribution and interactions in the Northern Bering Sea. So they're looking at how changing ice cover and food webs influence size, condition, and abundance of crabs, fish, seabirds, and marine mammals. And their hypotheses include that warming temperatures and early ice retreat negatively affect benthic species and positively affect some pelagic species. That warming temperatures lead to earlier hatch timing and larger size at age, but negatively affect body condition of juvenile and subadult pelagic fishes. That cold pool dynamics will affect species distribution, predator-prey interactions, and bottom-up versus top-down controls on populations. So that's looking at whether the populations are controlled by things like changing environmental conditions and prey availability or predation. And they hypothesize that warming will accelerate the arrival of migratory fish, bird, and mammal species and transition the Northern Bering Sea away from primarily juvenile habitat for many species. So they will be working aboard a chartered fishing vessel, the Northwest Explorer, in the Northern Bering Sea in September of 2026 through 2029. I believe their dates this year are scheduled to be August 24th through September 23rd. And they'll be focusing in this area circled here on the map. And so, as I mentioned earlier, they will be leveraging the standard NOAA surface survey that happens in the Northern Bering Sea. And they will also be adding for this integrated ecosystem research program, these samples that you see here in the red squares. So extending that survey grid to the west, so that even if we get a year that's relatively warm, hopefully they'll still be capturing some of that cold pool at the western end of that survey area. And they'll also be adding stations that are more relevant to the questions that are of interest to the folks on St. Lawrence Island. And then they will also be using data collected by NOAA's standard Southeastern Bering Sea survey that plans to go out in 2026 and 2028. And so one important thing to note with these projects is even though we will only be collecting data in 2026 through 2029, these projects are leveraging data that have been collected over the past 25 years throughout this ecosystem, especially by some of these NOAA surveys. So it will really allow us to put our data into a longer context. And some of those data in past years were collected in warm conditions and others in cold. So it should give us some nice opportunity for comparison by looking back at those historical data. So one of their objectives is to look at how variation in sea ice cover affects benthic pelagic energy pathways, food web structure, and their consequences. So for each of these objectives, you'll see that they have focal species. They have a list of species that they'll be looking at to answer these, to address these objectives. Some of them being pelagic species and some being the benthic on the seafloor. So I won't read them all out, but you can see that for each of these objectives, there's a number of different species that they will be looking at. The second objective is to determine how environmental conditions affect rates of fish growth and maturity. So they will be doing some controlled experiments in the laboratory, looking at how fishes are growing under different, for example, temperature conditions. They also aim to determine if and under what conditions juvenile fish and crab populations are limited by environmental conditions and prey availability versus predation. And there's quite a list of species they'll be looking at here, so I will linger on this slide for just a moment so you can look at those. They also aim to study timelines of transition, so looking at the seasonal influx of fish and marine mammals, the size and age of fish, and species distribution. Again, quite a few species they plan to look at here. And their fifth objective is to develop models to better understand Western Alaska salmon survival, groundfish and crab interactions, and the expansion of populations into the Northern Bering Sea. So to do this, they will be, again, using that standard NOAA surface trawl, looking at the juvenile pelagic fishes and invertebrates. They'll also be using this beam trawl. It's a relatively small trawl. You can see the man in this photo for scale. And they'll be doing sampling the benthic environment, the fishes and invertebrates there. They'll also be doing some sampling of the benthic infauna using a sediment grab. So they'll be looking at those worms and clams and other organisms that are in the sediments. And they'll also have marine mammal and bird observers on the research vessels, as well as putting out some acoustic devices. They'll have a few upward-looking active acoustics devices like you see here on the left that will be looking at the fish and the zooplankton in the water column. And they'll also on the moorings have hydrophones that will be listening for marine mammal calls, as well as the sounds of ship traffic and ambient noise. Another important thing to note with all of these samples they're collecting is that they will also be contributing samples to the NOAA EcoHab project that they're collaborating with. And so samples of everything from the zooplankton to benthic invertebrates to fishes and marine mammals will be analyzed by folks involved in the EcoHab program to look at harmful algal blooms and toxin transfer through the ecosystem. They'll also be working with subsistence hunters who will be measuring seal body condition and collecting samples for diet and mercury analyses. And here's a photo of Orlin, the student from Savunga, who's going to be doing those mercury analyses. And here's Rob's contact information. If you don't happen to catch him for a question tonight, he's happy to take questions about his project via email as well. I want to say a few words about our plans for communication throughout the program. We do plan to be sending daily updates from the vessels, letting people know where the vessel's working that day, what it's doing, and where it plans to be working the following day. So if you'd like to be included on those daily updates, you can share your email address. My email address will be at the end of this presentation, and you can feel free to send me an email and let me know that you'd like to be added to our daily email distribution list, and I'll make sure you get on it. If you're here and you'd like to drop your email address in the chat, I will grab it from there as well. If you see an update and you are concerned that the vessel may interfere with something like subsistence harvesting that you plan to do the following day, you can always get in touch with the vessel and they will adjust course and make sure that they're avoiding any opportunities for conflict with subsistence harvests, for example. We'll be sharing information via Norton Sound Health about any harmful algal blooms or other human health related findings that may come up while we're out in the field. And Emma Pate is going to be instrumental in helping us to make sure that we are doing that right. And we're really glad to have her on our team. We will be distributing that integrated science plan as soon as we have it finished, and it will be up on our website. It's going to provide one coherent document that lays out where and when we'll be working, what we'll be doing, and who to contact for questions about any of the science. And so we will get that out as soon as possible. We are also hope that we'll be invited back to give more of these presentations for Strait Science, and hopefully in the future you'll be hearing directly from the scientists who are leading these research cruises and getting their fresh off the boat observations. We do plan to make annual visits to St. Lawrence Island immediately following the meeting in Anchorage, where we had folks from St. Lawrence come to our meeting. A team of our lead scientists went to St. Lawrence Island and were on the ground with people in Savunga. And so we look forward to continuing to do that over the years. We also plan to be giving presentations to Alaska Native Co-Management organizations at their annual meetings whenever they are willing to put us on their agenda. In the past, we've given presentations for IPCOM, the Indigenous Peoples Council for Marine Mammals, which is the umbrella organization that includes representatives of almost all of the other Alaska Native co-management organizations for marine mammals in the state. We've also given presentations for the Alaska Eskimo Whaling Commission, Eskimo Walrus Commission, the Ice Seal Committee, the Alaska Beluga Whale Committee. So we're very happy to continue doing that as well. We have a number of outreach products that we're discussing. We have a team of communications experts who are going to be putting their heads together in the very near future to talk about some of the exciting ideas that we have and just decide which ones make the most sense. We have our collaborators like Emma Pate and the Native Village of Savunga helping us figure out which they are most excited about pursuing. As far as outreach products, I just wanted to share a few examples in the context of that previous Arctic program that I spoke about earlier. We produced a series of videos, and if you haven't seen them already, I encourage you to visit our website where you can see all of them. One of them is focused specifically on how communities played a role in the research, and so you'll get to hear directly from people like Opika Kinga of Little Diomede, who participated in our research cruises and is she's really taking a leadership role in science in her own community now. So I encourage you to have a look at those. When our Arctic program concluded, we produced a brochure that summarized all of the results, and then we sent USB thumb drives along with that brochure to a distribution list that included over 115 different tribes and tribal organizations in the Bering Strait, Northwest Arctic, and North Slope regions of Alaska. And on those thumb drives, we included a digital copy of that brochure, but we also included copies of all of the final reports from the science, so literally thousands of pages of science. We also included copies of those videos that I just showed you, as well as information about how people could access the data. So all of the data collected by the program are public. And so we do have a data portal for our Arctic program. So all of the data collected by that past program are public and available now. I also wanted to bring this image up again. You'll see that this time I have a QR code there, and if you pull up your mobile phone and you scan that QR code, it should take you to a version of this image that's broken up into 4 panels. And each of those 4 panels has some yellow hotspots you can click on that will expand and tell you more about that aspect of the ecosystem and sort of what we were learning through that in the context of that program. And that was developed to be part of an exhibit that is launching at the Anchorage Museum tomorrow evening. We're very excited about the opening of this new exhibit that will showcase the results of our Arctic Integrated Ecosystem Research Program alongside a lot of other really wonderful work that's happening as far as Arctic marine science. So if you happen to be visiting Anchorage in the coming year, I really encourage you to stop in at the Anchorage Museum and have a look. But that QR code will be on the wall there so that visitors to the museum can scan it and explore that diagram and learn more about the program. So I just want to share again the contact information for some of the folks that are really leading the science side of this effort. I will just leave these email addresses on the screen for a moment. On the next slide, I have contact information for myself and a couple of my colleagues at the North Pacific Research Board if you'd like to contact us as the funding organization for this new program. So there's my email address. And I'm also sharing the contact information for our science director, Dr. Matthew Baker, as well as our communications and outreach director, Brendan Smith. And I believe that is my final slide. So with that, thank you very much for having me. I really appreciate you taking the time to learn about our program, and I look forward to sharing the results of this program over the next several years with you. Thank you so much.
All right. Wow. Thank you, Danielle. And everybody's so good. This is the time as Straight Science audience is a nice group of people, and we always put a little love in the chat or give some emojis nowadays for you bringing information to us regarding what's going on and what's about to start this very large and complex research effort. So thank you very much, Danielle, for giving that to us tonight. You can also use the chat, but people are so good now on the emojis. I don't know if you see all that.
I do. They're really fun. Thank you all.
Yeah. So we'll open it up to questions, thoughts. I know I've got a question or two. We'll see if somebody else wants to start off. All right. So my question is North Pacific Research Board. So out here on the coast, we're aware of NOAA fisheries and NOAA marine mammals and Fish and Wildlife Service, marine mammal, walrus. And we see all these University of Alaska Fairbanks, University of Washington. We see all these. And so NPRB is really, can you talk a little bit about like where the funding comes from? Because it's not really NPRB coming out per se. We're going to see a lot of the people we know in the region. And how does that work, I guess, for us on the coast so we can kind of understand NPRB, which is in Anchorage, which serves as like a funder and your board and your advisory panel and whatnot. They're directing what science should get done and then offering monies for right now for the next 5 years. That would help us because we see people, some of this people that you're mentioning here, they come every year, but so I don't want to make it kind of confusing. Is that a way to sort of lock in on what is NPRB and their role and that funding, sort of where that comes from and how it works as it
Yeah.
moves across the state again and again?
Oh, yeah. So NPRB gets our funding. There's a fund called the Environmental Improvement and Restoration Fund, and we operate on 20% of the interest generated by that fund. And so our money is nice in that it's relatively stable. It doesn't come through congressional appropriations on an annual basis. So we know what's coming based on, interest rates. It's a fund like something like similar to the Exxon Valdez Oil Spill Trustee Fund, something like that. And so we don't have to rely on Congress to pass our budget every year to know what's coming. And for these integrated ecosystem research programs, you mentioned kind of like moving around the state. The board will decide to, based on, a need for information, where's the next area where we really need to understand those processes in an ecosystem. Things are changing. We need to better understand what's happening and take a holistic approach to it. So they'll invest a large amount of money in one of these 5-year multidisciplinary, multi-institutional programs. And so the first one that was done and started in 2007 was in the Bering Sea, but mostly kind of the southern Bering Sea. Then we did the Gulf of Alaska, then the Arctic, the Chukchi, and now the Northern Bering Sea. And so we only have one of these big programs going at any given time because they're just so expensive and difficult to manage. But we do have other research going on throughout the state of Alaska under our other programs. So we have a core program that gives out money for more narrowly focused projects, things like an oceanography project or a fish project or a project on marine mammals. And those projects can be funded in any year, and they will happen anywhere in Alaska waters. And
Awesome.
um, and also, you mentioned the advisory panel, so I want to recognize that Gay served on our advisory panel for quite a long time and was really instrumental in helping guide research on our AP. So we have a science panel and an advisory panel. So when NPRB gets a science proposal, it first is reviewed by a science panel and they look at the rigor of the science, and then it's reviewed by the advisory panel and they look for particular stakeholder and community relevance. So, and the advisory panel will endorse a project as having particular community or stakeholder relevance to kind of raise it when the board looks at it. And the board does consider very strongly whether a project has the endorsement of the advisory panel when they decide to fund it.
Right. Well, thank you. That helps because sometimes you hear about NPRB research and you kind of think, are they a research organization? Are they like a agency? So there's that you facilitate a lot of research, that North Pacific Research Board, because of that
Okay.
fund. And that's really a great opportunity because, as you said, a lot of funds can get cut or they're locked into the no man land of like a shutdown and things like that, but not NPRB's money.
Right.
You're coming out of a totally different um, avenue, which
Right.
allows for this sort of thing with a lot more stableness, I guess, these
Yeah.
days.
And again,
That
it's
helps.
also, I think, important to note that we're not a resource management agency like a federal agency. So we ourselves do not do any sort of resource management like fishery management. We provide money to fund science, to gather data that is hopefully relevant to resource management and to communities, but we don't have any management authority ourselves at all.
Right. And that's super helpful to clarify that because we have so much marine resources here and sometimes it can get like, huh? So thank you very much. That's a really good explanation of that. So, any other questions? Comments? We've got lots of good people on here. I guess you did it just right. Everybody's stunned and awed and got their answers. I'm putting down to your board of directors and that I've tried been going with that so people can see who's when they're picking science, how who is the leadership of NPRB.
Thank
Because
you.
again, the Bering Strait region, I know if you live in Anchorage, that's something that's the warp and weave, or if you're involved in the science world, you kind of know what's going on. But on the coast here, we only see you guys when you're doing these big science uh, projects. So that's really great.
Thanks.
And you have a question in the chat. Do you fund bird and marine mammal tagging?
So we don't have any tagging of birds or marine mammals going on in the context of this Northern Bering Sea Integrated Ecosystem Research Program, but NPRB can fund marine bird or mammal tagging. We do, and you can submit a proposal under our core program if you're interested in doing that.
All right. And I see Stacy Lukinson wrote, Koyana Danielle, this is a very useful presentation. Thanks for touching on the policy implications of this sort of work. Does NPRB have a place for when there is community interest, but not yet a rigorous science plans?
Um, Thanks, Stacy. I'm trying to understand your question, and I'm wondering if you mean in the context of this Northern Bering Sea integrated program or just in general, uh, for example, through our core program.
I think I'm asking in general, like if there were people from a community, I know HABS has come up and is very well integrated in this plan, but that sort of issue where people have like an interest in food safety, or an interest in like water, how much salinity is in our water. It's like extra thick, this, whatever. Like I know that's sort of a weird phrasing of it, but if there's a place where folks who live in the community year round, and want to basically ask science questions, but don't have a scientist to build them a whole plan and write a core proposal.
It's a really good question. I think in the context of these integrated ecosystem research program, actually in the near term, there's, I think, a lot of room for that to come into this program. Folks like Emma Pate, we have people who can help to connect folks with our program, and we do have people in our program getting together every year. And so we can talk about if somebody has an interest in something, if it's something that could be added to the context of what we're already doing, then that's something we could certainly do. Aside from that, we have a long-term monitoring program. And under that program, there is the space to collect data for the sake of monitoring something. However, the core program, which is where most of our proposals come in, you really do need to have a science-focused question that you're pursuing, not just collecting monitoring data, but you have to have a plan for a science question that you want to answer using the data. So I guess that's sort of my short answer for that. And I'm happy to talk more offline with you and explore ideas if you'd like.
Yeah, actually, oh, go ahead, Stacy. All right, she's giving you the thumbs up. That's good. And if you're looking for, it sort of sounded like to me you're looking for input from regional entities like Queric, like tribes.
We certainly welcome input and engagement. We have like a funded science program now, and we don't anticipate necessarily having another like big call for proposals for this Northern Bering Sea program. However, we have a wealth of research going on in the context of this program, and we're always happy to talk with communities about how the data could be useful to them, how we could add sampling in the context of what we're already doing if we're not already collecting data that they want, or how we can share results or include them in the analyses of the data if they're interested in that. So there's certainly a lot of room for new and additional collaboration. And I think in some cases for even some of these projects where we plan to involve community members in the science itself, some of those individuals may not be identified yet. And so if you're interested in being one of the people who is engaging in the science, please reach out to me or Emma, and we will figure out, where we can plug you in.
All right. Oh, and Andrea had written eDNA projects as well as funding bird. So I would say that depends on your funding cycle and your topics. Is that right?
Yeah, I mean, we are
Mhm.
certainly interested in proposals for eDNA projects. Under the core program, we do have eDNA work going on in the context of the Northern Bering Sea Integrated Ecosystem Research Program as well. We have quite a lot of eDNA work.
And I'm just putting down here your current funding page opportunities.
Thanks. Yeah.
Opportunities.
Our core program dropped out a lot of the funding last year to make space in our budget for this new Northern Bering Sea Integrated Ecosystem Research Program. But we do have a new RFP that's planned to come out in October that will be another large opportunity for funding under the core program. So keep an eye on our website.
All right. Stacy says, thanks, Danielle. We can definitely talk offline. Book. Where's my mouse? And Emma's put her email address in. Thank you for doing that, Emma.
Yes, thank you, Emma.
Stacy said, Koyana, Danielle, this is a very useful presentation. Thanks for touching on the policy implications of this sort of work. Does N, oh,
Oh,
no, I
that's
think I
the
read
one from
that one. Wait a
earlier.
minute. Hang on. Thanks, Danielle. We can definitely talk offline too. Just hearing about the start of some ideas, likely monitoring style projects in communities, and it sounds like NPRB might be able to match those up with science that is happening.
Yes,
So
we
thank
should.
you, Stacy, and thank you, Emma. Emma Pate at necalaska.org, in case anyone wants to check in. I think that's brilliant. Thank you, Stacy, and thank you, Emma. All right. Any other questions, concerns? Well, I hope we see I know I've already sort of hit up some of the leadership of those three big efforts that are coming between now and 2030.
Yep. So we
Okay.
have field work 2026 through 2029. And the program itself wraps up in 2031. So it gives the scientists a couple of years to really analyze their data and work on it for a couple of years after they finish
Right.
collecting it.
All right. So maybe we'll have more updates coming. And once again, any other comments and thoughts? All right. Thank you, Stacy. And with that, I don't know, Danielle, if you want to stay on for 1 second while we send all these nice people off to have a late dinner or an early fun evening outside. The next Straight Science will be next week on a Wednesday. It's going to be a Wednesday, and we're going to have University of Arizona's Arctic Lab, who are doing multi-projects out on Gamble, Civicock, and they're going to be talking. We're going to have some of the speakers will be from Gamble, as well as the Arizona State University, and this will be led by Abigail York. And they've been talking with people, working with people regarding the sea ice loss and changes to everyday life. And so we'll hear the results of that research on Wednesday, not Thursday, on Wednesday, May 20th, next week. So that should be very interesting. And again, Danielle, thank you so much for coming and sort of kicking off the North Pacific Research Board effort that will include all the people that have got the funding and that we'll be seeing up here. So locally and remotely. With that, have a good night, everyone, and we'll see you next Wednesday evening. Have a good
Thank
night,
you so much.
everyone.
Thank you for having me.